controlled and recorded by radar and photography. Control of air movements during and after the tests must also be guided by many other factors, particularly those of radiological safety. By 0800, General Kepner is able to report that all aircraft are airborne and that the bomber is over the target array preparing for its first dry run. Aloft, visibility is good. The dry run is successful, and at 0849, Admiral Blandy signals for the start of the bombing run. Dave's Dream is at 29,000 feet. True airspeed is 299 miles per hour. The bombardier makes corrections for wind and bomb weight, and a small compensation for the inherent tendency of this type of bomb to hit short. Bomb bay doors are open. The timing signal sounds. Only seconds left to go. On the cry, bomb away, the world's fourth atomic bomb plummets earthward. As the bomb bay doors snap shut, the bomber executes her 150-degree turn to the left. Closest photographic aircraft is the F-13, which from a position 1,000 feet to the right of Dave's Dream takes motion pictures of the bombing run and photographs descent of the bomb. Instantly upon bomb release, two B-29s drop blast pressure recording instruments into the area above the target. This equipment settles into position over the array. Falling for slightly more than 48 seconds, about 500 feet above the surface of the lagoon, the bomb explodes. Unfolded are a myriad of majestic, startling, and awesome effects, a panoply that only the cameras can record in faithful detail. The most important events of atomic explosion occur during the first fraction of a second after detonation. Nuclear reaction is completed within a few millionths of a second. Then comes a brilliant flash of bluish light that overwhelms the vision of even distant observers and blanks out photographic lenses. In these heavily filtered, high-speed photographs, the flash is subdued to a glowing orb. The motion has been frozen for better discernment of the progression of events and for study of the early phenomena. This ball of fire, less than 1/100th of a second old, has a diameter of about 180 yards and is expanding at the rate of 10,000 feet per second. Before this stage is reached, gamma rays and neutrons have already escaped to produce their lethal effects. Energy equivalent to 20,000 tons of TNT now resides in this incandescent sphere as heat and pressure. Losing brilliance rapidly, it is still almost as bright as the sun. Its internal temperature, fed by nuclear energy, is reckoned in millions of degrees. Its pressure is almost a ton per square inch. At 2/100ths of a second, the ball of fire has flared to a 250-yard diameter. Less rapid is its expansion now, and a shock wave, outracing the fireball and carrying nearly half the total energy of the explosion, rushes out at 6,000 feet per second to batter the target ships. Hitting the water, the blast wave produces a reflection that rejoins the original shock, multiplying the pressures and increasing the damage. When the wave strikes the water, it produces a white circle of spray. The expansion rate of this circle provides the best method of measurement of shock wave properties. For almost a full second, excessive pressure prevails around the fireball. Then this pressure gives way to partial vacuum. Intense heat evaporates inflammable material and explosive mixtures are ignited. Flames belch against the sides of the vessels. Fires break out. Sudden rarefaction cools the surrounding atmosphere until no longer can it carry the water vapor associated with high humidity over the tropic sea. A dense cloud forms into a beautiful white hemisphere, enveloping the blazing ball of fire. At this juncture, damage from the intense heat and light radiation ceases. This supersaturation effect diminishes the number and the violence of fires as compared to atomic explosion over dry regions. High winds associated with the shock wave snuff out many of the fires which the intense heat already has created and smite ship superstructures a staggering blow. As the cloud chamber begins to dissipate 5 seconds after detonation, a ring cloud forms, soon to be evaporated. Within this emerging fireball, there yet remains a great store of energy. Turbulent and still glowing, it shoots up with an initial velocity of 150 feet per second, carrying off all but a fraction of the deadly fission products. As incandescence disappears, the mushroom cloud develops. With powerful up-thrusting surges which seem to regenerate themselves again and again, the mushroom cloud becomes a boiling mass of energy filled with toxic gases, conflicting winds, twisting flames, and superheated air currents. The cloud assumed its characteristic shape 20 seconds after detonation. The lengthening stem and the bulbous head give it the appearance of a gigantic flower trying to span the distance between Earth and sky. Less conspicuous because of its transient nature is the froth of base cloud, soon to be sucked up into the stalk of the mushroom. At 18,000 feet, approximately 2 minutes after detonation, a thin, wraith-like cap of ice crystals has formed, quickly swallowed by the rising cloud. Within 150 seconds, the cloud has reared its majestic pillar up to 5 miles, roughly the height from which the bomb had been dropped. By 400 seconds, it has risen to 7 miles. Eventually, it reached 40,000 feet, but by this time, shearing upper winds have been whipping it to shreds. Drifting in the winds, the cloud stratified and lost its shape. Within an hour, observers at Bikini could see it no more. For many hours, reconnaissance aircraft tracked its wind-borne wandering. Later, from remote points, came reports that traces of increased radioactivity had been detected. On the way to the target array, 9 minutes before detonation, one F-6F drone developed an inoperable aileron at 28,000 feet, spiraled out of control and crashed. With this exception, the flight plan of the drone fighters was carried out with notable success. Landing at Roy, the Navy drones brought back a wide variety of scientific data and samples. Equally notable was the success of the drone bombers of the Army Air Forces. Every drone aircraft was recovered on completion of its mission and safely landed at Eniwetok. This was a remarkable record, as a high rate of loss had been expected in the remote-controlled flying operation. Instead, there was not a single abort for engine failure or other mechanical reasons. Primary mission of the drones was to gather air samples in dust-collecting bags and in air and oil filters, and to carry both television cameras and recording instruments into areas too dangerous for operation of manned aircraft. All drones also served as airborne targets to determine the effects of atomic blast upon aircraft. Its automatic cameras grinding out a photographic record, one B-17 drone was flown directly into the center of the radioactive cloud at 24,000 feet, approximately 7.5 minutes after detonation. 3 other B-17 drones were maneuvered around the outskirts of the cloud at 13,000, 18,000, and 30,000 feet. 3 drone fighters completed their transits into the cloud at 10,000, 15,000, and 20,000 feet. The drone which entered the cloud at 20,000 feet had a slight nose-up position upon entry and emerged at 26,000 feet, evidently caught in strong updrafts within the cloud. Temporarily astray, this drone was not recaptured by its control plane until 43 minutes later. It was then over Wotho. The radio compass aboard one B-17 drone proved its value when, remotely keyed, it turned the bomber toward Eniwetok while the distant control plane was attempting to overtake it. Because of its reserve fuel load, a critical factor at 30,000 feet in affecting relative speeds, the mother aircraft did not overtake the drone for 15 minutes. At Eniwetok, residual radioactivity was measured. Some of the aircraft were designated hot, their air samples indicating they had flown through areas of severe radioactivity. Airbags had been opened by AGSTOT relays when the planes were visually inside the cloud or when Geiger counters indicated they were in dense radioactive areas. The bags were closed by the radio relays 15 seconds later. Air filters allowed air to flow freely through filter paper, forming deposits of radioactive material. Oil filters also were used to collect deposit samples of the cloud. The strongest samples of radioactivity were obtained from aircraft which had flown through the cloud at higher altitudes. All drones carried flight analyzers which recorded normal accelerations, air speeds, pressures, and altitudes as functions of time. Because they were distant from the epicenter at detonation, the drones did not experience any marked acceleration from the shock wave. Air currents did produce mild accelerations of the drones at the threshold of the cloud pillar and within it. As far as engine performance is concerned, it was established that aircraft can operate close to atomic explosion. The drones carried a great variety of electronic equipment for testing. Results of electronic investigations were generally negative. So little electronic or mechanical interference or malfunction was recorded that it may be strongly assumed that radio-controlled drones or electronically controlled rocket missiles can be used successfully in areas close to an atomic explosion. Radioactivity had little effect on transmissions. A strange effect was produced upon the iconoscope of the television camera in the nose of the B-17 drone which entered the center of the cloud. The light intensity of the detonation was so great that a miniature image of the early blast was burned permanently on the screen. The iconoscope is being preserved at Wright Field. No radar reflections were obtained from the blast cloud in Test Able. Attenuation of signals which passed through the cloud was observed, the phenomena lasting as long as 7 seconds at the higher radar frequencies. A few minutes after detonation, the BGOR, jointly controlling the drone boats with the aid of aircraft, approached the lagoon for visual control. At the same time, 4 TBM planes were launched by the Sidor with conning officers and radiological safety monitors aboard. 44 minutes after detonation, the first drone boat, an LCVP, its stern trailing a cloud of smoke to identify it to the control planes, started toward the target array to collect water samples. Another followed a short interval later. Within 4 hours of detonation, these radio-controlled boats had collected a number of water samples which were immediately flown to Kwajalein for analysis. Other aircraft were performing important functions. A PBM equipped with special radiometry instruments to photograph and measure the heat radiation of the blast orbited the target array at 9,500 feet and 15 miles slant range. This equipment produced particularly valuable scientific data. Radiological reconnaissance aircraft and photographic aircraft continued their flights for a long period after detonation, being replaced periodically by relief aircraft. These crews acquired a steady flow of the data necessary to maintain an uninterrupted record. 3 seaplanes carried equipment for photographing and measuring water waves resulting from the burst. The crew of one of these planes also actuated by radio the synchronized tower cameras on the islands. Close inspection of the damage wrought by the Able Day bomb awaited completion of safety precautions. Through binoculars, the distant watchers had seen a number of fires break out. They had strained to identify the ships involved. As the blast wave passed over the ships, observers had noted a black cloud above each vessel. Scientists believed that these clouds consisted of soot and dirt shaken loose by the blast and forced out of the stacks and boilers of the ships. Salvage units awaited the signal for re-entrance to the lagoon. These units were equipped with safety helmets, rescue breathing apparatus, mine appliances, and other instruments designed to detect and measure noxious and explosive gases. 5 hours after detonation, after careful radiological survey by the safety groups, the word came from Admiral Blandy, re-enter. As units steamed into the lagoon, full import of the tremendous effect of the atomic bomb became immediately apparent. Spread over the oil-splotched lagoon, observers saw a vast array of smoking, soot-smudged vessels as if the remnants of a great naval conflict.